channel Simplified Organic. So today I am going to discuss about Fajan's rule in chemical bonding. Some rules called as Fajan's rule. So in nature, no bond is 100% covalent or 100% ionic. No bond is 100% covalent or 100% ionic. But we can compare the percentage of compare the percentage of covalent character or ionic character in some compounds by using these Fajan's rule. So in ionic bond there will be some covalent character. In covalent bond there will be some ionic character. So when some compounds are given to you, how can you identify which one is more covalent or which one is more ionic? So for this we can follow these Fajan's rule. So rule number one. Rule number one says that smaller the cation size, more is the covalent character. More is the covalent character. Like for example, if I take lithium, sodium, potassium, rubidium and cesium chlorides of 1A. In this case, the anion is common, chlorine is common. Now the covalent character depends upon the size of the cation. So lithium being smallest in size, smaller the cation size, more is the covalent character. Therefore, lithium chloride is most covalent in nature. Now cesium is very large in size, so therefore least covalent. So what will be the order of covalent character? Smaller the cation, more is the covalent character. So therefore covalent nature decreases. Therefore ionic nature will increase. So if the question is asked which one is most ionic, so then we can give cesium chloride as the answer. So this is the rule number one. Now rule number two. Larger the anion size, more is the covalent character. Larger the anion size. Like for example, lithium fluoride, lithium chloride, lithium bromide and lithium iodide. So now in these, lithium is common, so therefore the covalent character depends upon the anion. So larger the anion, more is the covalent. So I minus being large in size, therefore this is more covalent, and fluorine F minus being smaller in size, it is less covalent in nature. So this is the second rule number two. Now rule number three. Let us talk about rule number three, which says greater the charge, whether it is positive charge or negative charge, greater the charge, more is the covalent character. Like for example, if I take sodium chloride, magnesium chloride and aluminium chloride, in these three, anyhow anion is same, Cl minus, so negative charge is same. minus 1, minus 1, minus 1. But sodium plus 1, magnesium plus 1, magnesium plus 2, and aluminum plus 3. So greater the charge, more is the covalent character. So therefore, AlCl3 is most covalent, then magnesium chloride, then sodium chloride. This is about the rule number 3. We can also think, in this example, like we have magnesium fluoride and magnesium oxide. So here you have plus 2 common. This is minus 1, this is minus 2. So this is more covalent in nature. So coming to rule number 4, last rule number 4, which says that compounds or ions with pseudo inert gas configuration, are more covalent than inert gas configuration compounds. Now, for example, if I ask you between KCl and CuCl, which is more covalent in nature? Now, if I write the potassium K plus ion configuration, that is neon 3s2 3p6. So here you have 8 electrons in the valence shell. Nothing but inert gas configuration. And if I write the configuration of Cu plus, that is neon 3s2 3p6 3d10. So in the valence shell there are 18 electrons in the valence shell. This is called as pseudo inert gas configuration. Inert gas means 8 electrons in the valence shell. Pseudo inert gas means 18 electrons in the valence shell. Okay. So now the statement, the rule number 4 says compounds with pseudo inert gas configuration are more covalent. So therefore CuCl is more covalent compared to that of KCl. So these are the 4 rules to be followed, 4 rules of Fajan to follow the covalent nature or ionic nature in a given compounds. Thank you very much. We'll meet in the next video. Keep watching my videos and subscribe my channel. Thank you. Bye bye. Take care.